Welcome to Amplion's audio brief featuring our 700 watt L-band GaN on silicon carbide HEMT transistor. This transistor is a 50 volt 0.45 micron process configured onto a thermally enhanced package in either bolt down or solder down package styles. This transistor has been specifically engineered for high power performance while operating under long pulse signals, all the while maintaining a reliable channel temperature under 225 degrees C. The long pulse capability supports 2 millisecond pulse width at 20% duty and can approach CW performance depending on case temperature. Further, the transistor has a number of reference designs to suit various applications: avionics bands from 960 to 1250 and 1030 to 1090, as well as L-band radar from 12 to 1400 megahertz. Let's take a closer look at performance plots at an L-band design under Class AB bias. This plot shows power gain on the left vertical axis, efficiency on the right vertical axis, and frequency on the horizontal. At 700 watts fixed pulse output power, the gain shows greater than 17 dB and efficiency greater than 64% over the entire band. These features were taken under pulse widths of 3 milliseconds at 10% duty. Further, this transistor can withstand VisWAR mismatch up to 10 to 1 while operating under pulsed power. This plot shows compressed power at 3 steps, 1 dB through 3 dB compression. This demonstrates a high power linear region beyond 500 watts while transitioning to a saturated power region up to 775 watts. The transistor's thermal resistance will depend on pulse width and duty cycle for the specific application. The plot shows thermal resistance on the left vertical axis and pulse width on the horizontal. The plots of the colored line are duty cycles over the pulse widths. This plot will guide to a specific thermal resistance for the corresponding pulse width and duty cycle of an application. These plots have been verified with ANSYS thermal models as well as measurement techniques aligned with the model. Each specific application will require a careful consideration of the thermal environment. This transient thermal resistance plot will be a helpful guide. We are confident that the 700 watt GaN on silicon carbide HEMT transistor is an excellent candidate for your most demanding high power L and avionics bands for short as well as long pulsed applications.